Hi, I'm Teresa Tung, and I'm Accenture's Global Data Capability Lead.
Wonderful. I'm Marshall Kirkpatrick. Thanks so much for joining us.
Good to meet you.
You too. Teresa, will you tell us about what brings organizations to confidential computing? What kinds of pitfalls and problems do they experience that lead them to this world?
I think there's at least three. One is just having enough data to see what they need to see. So even without AI, just being able to see a complete picture. Oftentimes, one part of the business or one business doesn't have the whole thing. So even if you were looking at a customer 360, you probably have data about prospective customers, you have data about customer transactions, about customer service. Those might be from different parts of the business that might not be able to share data so easily. And then even to get that fuller picture of customer 360, you're going to need third-party data, but data from your partners. And have you ever asked your data lake or mine? No one's going to give you their data, right? So being able to have a way to protect your own data because it's such a competitive advantage is really one of the big drivers. I think another that we see is around the IP itself. So the models. So just like I don't trust being able to share data, I might not want to share my model with another party. So an industrial manufacturer might need to service their customers with AI-enabled capabilities that deploy within, factories or data centers. As you do this, their customers will now control their IP. And you don't necessarily want to do that if you're this industrial manufacturer because you're giving it away. So being able to protect your IP is another one. And then finally, I think in this age of generative AI, like it or not, most of the easiest ways to adopt generative AI is using a managed model or a full stack application from somebody else. And as we do this, we don't want to inadvertently give up some of our, again, confidential IP and private data. So these are three of the patterns that I see.
That's really, really helpful. So let's say an organization is struggling with one of those patterns and comes into the world of confidential computing and succeeds in implementing a confidential computing initiative. What comes next? What are the positive business outcomes? What is newly technically capable? What are the benefits of solving those problems you discussed with confidential computing?
Companies who start with confidential computing are likely targeting it in one use case, right? The first use case could be within clinical trials, could be within customer service, right? You're starting in one place. And by doing that, you're proving out two things, right? You're proving out the value of the use case that you couldn't have done before without confidential computing. So being able to prove that you can unlock data, work with partners, get the right insights that are correct without needing to do maybe some of the harder things that we used to have to do to be able to share data in a you had to identify ahead of time what you were going to do with the data. And it was really hard for some of the AI algorithms to be able to act with some of the limitations. So one is just the value there. I think the second now is that you have this capability that is turnkey, that you can scale across other data across the business, right? You've proven out this capability that is secure and it works. And so that capability that you can now have with different use cases, use case 2, 3, 4, right? That becomes much easier to scale. So I think it's both scaling the initial case and then scaling all the subsequent cases.
So each successful implementation compounds in value across multiple use cases, potentially across an enterprise.
100%. 100% each use case compounds both in terms of scale of that initial case, but in terms of subsequent cases, creating a more combinatorial effect. Right? As you have more data protected in this way, you could see more across your business and create more cross-functional outputs.
Can you tell us a little bit about what that means in terms of data? What kinds of new insights or new capabilities become available in an AI context that is enabled by confidential computing as these use cases scale across an enterprise?
One example of using confidential computing across an enterprise is around a retailer. So this retail, it's a conglomerate and they own a lot of retailers. So think about like a shopping mall where there's a lot of stores within that same space. So each of the stores might have their own loyalty program. And again, your data lake or mine, no retailer is going to trust the other retailer enough to be able to share customer purchase and loyalty data. But it would benefit the entire shopping mall or that entire conglomerate if we can actually get better offers to the customers as a whole, right? If we can know people are buying luxury goods or they're buying things for the summer, each retailer would benefit. And as consumers, we would benefit. So the combinatorial effect that was able to be applied is one, we were able to start by scaling and having each retailer by adding more data to the use case in a safe and secure way. Now we could see more about the customer and better create offers. So that's one way of scale. The other way of scale would be to add just, much more use cases on it and better offers and ultimately increase customer satisfaction and increase sales. So we're really scaling in both dimensions.
Is there a new level of agility and speed and ability to innovate that becomes available to companies that are participating in that kind of multi-party data analysis enabled here?
There is a big boost to innovation for companies and across the functions within a company who participate in data sharing. Because if you're looking at just one siloed view, the most you can do is really optimize your own silo. But the bigger change comes across a company and more importantly, across an industry. If we just take something like supply chain, right? If I'm looking at just one part of supply chain, I might have my warehouse data and I can make my warehouse as optimized as possible. But that's not going to impact the network, and that's certainly not going to impact all the domino effects of my upstream and downstream partners. When my customer changes the order, when a delivery is coming in late, when a weather event or a bridge collapses, like there's all of this domino effect that happens. And without being able to see a full picture, it's really hard to address these. And it's also really hard to innovate because you only see data about your part. So, it's that parts of the elephant. We can't actually change the process. The process stays the same. We can only at best optimize for our step in the existing process versus being able to see the same thing. We might have a completely different process.
Are there new opportunities to innovate that become available to parties at a certain point in a multi-step process like a supply chain where it may lower the barrier to entry for them to create value added innovations that serve the entire network?
So using confidential compute does lower the barrier to innovation. Let me give you an example within supply chain. So just by seeing the same thing in supply chain across different partners, what's coming upstream, what your customers need, just by seeing that, I'm already getting a lot. But I wouldn't want to show it in the clear, right? By showing you what my demand is as a customer, what I'm willing to pay, that's really secret. Like I'm just giving you, the keys to my kingdom. So instead, if we can use in a confidential compute manner, like I can specify what I'm willing to pay, I can specify the demand, you can specify the price that you're willing to accept. So this is not a hard math problem, right? It's just a comparison and a match. And then we only need to see the final result about what we're each willing to pay and what the demand and supply needs to be, right? None of us actually revealed. So none of this is really hard AI. It was just seeing the same thing or just seeing the right thing, right? We're still keeping those secrets across for both of us. And then now when we want to apply AI to all of this, right? Being able to make sure that if I'm contributing data or you're contributing a model, that when we have an outcome, that everybody who made a contribution can have a means to be able to get credit for it. It could be literally monetary credit, right? To be able to track that. That's another benefit.
That's remarkable. How is your thinking changing now? What are some of the most recent strategic shifts and insights that you have come to when thinking about confidential computing and AI?
The biggest strategic shift has been generative AI. And I would say less from a technology perspective in terms of confidential compute, certainly using a confidential computing gateway or even an enclave for the whole running of the model or for the inferencing. That's certainly part of it. But I say the biggest change is that our C-suite and the board is asking the business, what are you doing in AI? Because generative AI has consumerized AI. It's part of the consumer expectation. And so to make sure that we're not disrupted, every business has kicked off efforts to say, well, what does this mean for us? This has never happened, right? So confidential computing, I wish that 2, 3 years, 5 years ago, that they kicked off initiatives to say, let's find all the opportunities confidential compute can actually address. I'm sure there's a lot of them, but it took generative AI to actually kick off those exercises, and many companies have done this. And so now the great thing is let's use that, right? All those ideas that people have, some of them are going to be addressed with confidential compute, and it's going to make the data that's needed to power the AI capabilities possible. And without confidential compute, all of those ideas are just ideas because there won't be data to service them and there won't be data to allow them to work in a safe and secure way.
So we're here at the Confidential Computing Summit hosted by Opaque. I wonder if you could tell us a little bit about your collaboration so far with Opaque Systems.
We've been collaborating with Opaque on a number of leading edge client proofs of concepts. So we've successfully done 2. I think one of them has been around being able to have different telcos, be able to see a bigger picture, to be able to improve the protections of cyber attacks for all of us. So each telco by themselves, they can see a part of the network, but we know that with some of these attacks, like these denial of service attacks, they're coming from all these parts. So if you have these different telco operators be able to share their data in a way that we can identify these attacks earlier on, that's better for the telcos, but it's really better for all of us. We're just all safer. So that's been one about just seeing the same thing. The second one that we did was really led with generative AI. So with generative AI, this auto manufacturer wanted to enable their dealers to be able to use that automotive's data to be able to better service us as the customers. So when I come in with a car and it has an issue, I want to be able to ask that dealer about my car. Each dealer shouldn't have every customer's data, right? It should only have data around the customers who come to that dealership. So we were able to use Opaque to be able to protect that private data around Teresa's car, right? Teresa's vehicle identification number, the particular order and ticket issue, and then in a secure way, use a gateway to be able to then strip out that PII data in a safe way and then replace it with tokenized data. So just a vehicle identification number, customer name. And then when we push that to the large language model that's managed by another party, there's no IP and there's no PII compromised. When the result comes back, now we reinsert within Opaque and in a protected manner some of that PII, and then it goes back to the dealership. So we're safe throughout, and we're really making sure that that dealer can only see the things that they should be able to see.
Where do you think confidential computing is going, ultimately, and maybe in the near term, maybe in the long term, and what's really important to you that the industry keep in mind?
I think the industry needs to be aware that responsible data is really important. So we hear a lot about responsible AI, and yes, you should be using AI ethically. Many companies are not adopting AI at scale just yet. Some of it happens with using the large language model. And so starting with responsible data is really key, because if someone else is implementing a lot of your AI, you might be using a full stack app created by a third party Pretty much every startup now is a generative AI startup, right? So with that in mind, as we're experimenting in that way, the data is really key. So even if you're not using generative AI yourself, whenever you're using somebody else's AI or somebody else's app, you need to make sure you secure your data. And the great news with confidential computing compared to other techniques is that it's much more turnkey, right? Anybody can get some of these secure enclaves in the cloud. You don't have to know ahead of time all the ways that you plan to process the data. You might not even need to know the data itself, right? It's the same solution. So a lot of the techniques that we did before, which was data specific or algorithm specific or possibly infrastructure specific, or it's hard to get, we all have checked that you've solved that.